Alright guys, so in this problem we're given the equation f of x is equal to 2x to the second plus 4x minus 6. Now you can see that this equation is given in the standard form, and in the first part of the problem they want you to express f of x in the vertex form. So the way that we're going to do that is by completing the square. Whenever you're given something in standard form and you want to change that into vertex form, you have to complete the square on that. And this is how it's going to look. So you always want to write down the original problem that they gave you. And you know that whenever you have to complete the square, you have to make sure that the term that's in front of the x to the second or x to the squared term is equal to a 1. In this case, you can see that that's not a 1. But you can make it a 1 by taking that 2 on the outside, by factoring that out. Alright guys, so this is what the problem looks like so far, Now, when you actually want to start with the completing the square process, this is what's going to happen. You keep that 2 on the outside, and you're mainly going to be working with whatever's on the inside of the parentheses. So for the first part, first two terms, nothing's going to change. And as soon as you get to the second term, to the third term that you're going to add right after that 2x, this is where you have to use that formula to complete that square. And I'm going to write that on the right side of the equation. B over 2 to the second power. This is the same exact formula that we use in the classroom. Now, a lot of kids have this question, they say, well, would the b be the original b that you had in the problem, or is it going to be the 2 that you have in this problem? And the answer is, it's going to be the 2, because if you plug in the 4, then that doesn't really serve the purpose. What was the point of taking out the 2 and then plugging that 4 in? So you got to make sure that you plug the b in after you factored out that 2. Alright, once you plug that in, you can simplify this, and that's going to give you 2 to the second, which is just 1. Raise that to the second power, and this is just going to be a 1. Now once you write this out, this is what's going to happen. You're going to close this parentheses, and here's the thing. What do you do with that negative 3 that you have inside of the parentheses? Well, you can't just get rid of that, so there's something that you have to do with that. Excuse me. So you take this 2 and you're going to multiply that negative 3 with that. So what's that going to give you? If you take the 2 and the negative 3, that's going to give you a negative 6. And now the thing is, there's something that you added in this equation. You added that positive 1. But the thing is, if you think about this, what's the number that you have in front of that parentheses? That's a 2, right? So you didn't just add a positive 1. If you multiply that 2 with that 1, that's actually a positive 2. So how do you cancel that out? Well, to cancel out a positive 2, you need to have a negative 2 on the outside of the parentheses. And at this point, you can actually simplify the stuff to complete that square and write that equation in vertex form. And this is how it's going to look. So we're going to write the x. The sign that's right after the x is a positive, so we're going to put that down. And the number that you added, which is highlighted, you would take the square root of that and put that inside the parentheses and then raise everything to the second power. And of course, the numbers that are on the outside of the parentheses, the negative 6 and the negative 2, once you combine those, that's going to give you a negative 8. And this is what the factored form of that equation looks like. So this answers that first part of the question. So whenever you see something like this on the IB exam, where it says express f of x in a given form, or express a certain function in a given form, all they're saying is you're taking the original function that they gave you and just changing that to put that in the form that they want you to put that in. Alright guys, let's move on to the second part of the question. Write down the equation of the axis of symmetry of the graph of f. Now the thing is, this is actually really easy because now you have the equation in the vertex form, and you know that the equation of the axis of symmetry is the same as whatever the h coordinate is or whatever the x coordinate is. And in this case, you can get that from the inside of the parentheses. The only trick to this is that that's written as a positive 1, and you know that whenever you write the equation for the vertex or equation of the axis of symmetry or the vertex, it's always going to be the opposite. The first coordinate is always going to be the opposite of what you have there. So the equation of the axis of symmetry is going to be a negative 1 and not a positive 1. There you go. That answers the second part of the question. Now in the last part of the question, they want you to express this thing in the intercept form. And the way that you're going to do that is by factoring out the original problem that they gave you. And this is how we're going to do that. Since we've already factored out the second part of the problem, we're not going to start from the beginning. We can just start from this since we've already taken out the 2. And this is an x to the second plus 2x minus the 3. Now this is factorable. You can see that if you write down 2 parentheses on this, the two numbers that would give you a -3 when you multiply them, and when you add those two up would give you a +2 in the middle, would be a +3 and a -1. And there you go. That's what the problem is, because if you compare this to the way that you have the equation written now, this is written in factored form, which is also known as the intercept form, because you can see that the 2x-intercepts, if there was a follow-up part to this question, you can see that you can solve for the x-intercepts from this. You can also get the y-intercepts out of this just by looking at the original equation that was given in standard form, which would be a -6. And of course, if they said that you had to graph this function based on the vertex on the two intercepts, on the 2x-intercepts, and then the y-intercept, you'd be able to do that. Alright guys, that's the end of the problem.